Rcast.
Welcome to the Climate and Coordination Rcast, where every week we'll be discussing topics related to all things climate change and RChain's role in the solution. We will be discussing technologies that can adapt and coordinate massive amounts of data like never before, forming social architectures that grow collective intelligence, sharing and evaluating data planetarily, all while maintaining personal privacy and personal data ownership. A new decentralized economy is forming as we move from the third industrial revolution, digitization, to the fourth, decarbonization. By building a co-op, built on a correct by construction, concurrent, scalable solution, RChain is structured to build out the new technology that will be required for a flourishing regenerative planet. Please join us on this journey.
All right. Well, I have something actually that I definitely that I would quite like to talk about briefly. Yeah. So I'll share my screen. Okay. So what you see is that you see a map of the world, and in the top left-hand corner, I think there's British Columbia, and there's a number 3, right?
Yeah.
So if we sort of move the map along, I'm moving the map along, and then I'm gonna then go into British Columbia. The reason it's 3 is because there's 3 eco-villages, and as you go further in, you can start to find out what they are. You can click on it. So there's the Rare Birds Housing Cooperative, right? This is part of the eco-village network, right? I'll come back to precisely what that is and how it works.
Okay.
And then you can have a look at that. And we can have a look at another one. So New Earth Mountain Village, right? I mean, there's some new agey things and some aren't. There's the Kakwa Eco Village Cooperative, okay? And if I sort of move the map all the way to Scotland, just to, because I talk about this place an awful lot, if I go all the way over here to the UK, you see there's this little one here. We're gonna, in Scotland, which is now sort of in the center of the map. And then I'm gonna just go into that one and then just click on this one. And this is the Fintorn Foundation.
Ah.
Right, so this is Fintorn.
Okay.
Right, so what you've got here is this map of all of the eco-villages, cooperatives in almost every instance across the globe, right, identified usually with a URL. I mean, some are just somebody's got some land and a house and they're beginning a journey to build an eco-village, whereas some are mature. What they've got in common is that they signed up to be part of the eco-village network. And I think why that's relevant to us at RChain is if we're building mechanisms for trusted collaboration, which is what we talk about a lot of the time. And we're interested in figuring out how can we help in a tangible way. One of the things that we could think about doing is partnering, for instance, becoming a member of the, or a partner of the Global Eco-Village Network. And not just that, but as and when RChat and RVote work, it would enable all of these organizations, there's an awful lot of them, to then collaborate across the globe, still with their local policies. They could even use it for local stuff. I mean, Fintorn probably would be interested because, there's about 1,000+ people at Fintorn. But the guy that's got a house and a few acres, he doesn't need to vote on anything other than with respect to the Eco-Village Network itself, because he's a one-man band. But it just got me thinking that as and when we've done we've used RChat and RVote, and it's been successful, it would be really nice to go find your nearest eco-village and have a check it out in some way, online or otherwise. Stay safe and all that. But check it out, because if they're using technology, some of these may eschew technology, sort of, the people that want to go back to the Middle Ages, but most of them don't. But they don't really know how they could use that technology. And I think there's the beginnings of a relationship that we could forge with the Ecovillage network itself to enable all of these little organizations to collaborate. So that's kind of what I wanted to put in front of people for this climate coordination call, because this would be climate coordination in action.
Mm-hmm. It's kind of,
let alone all the other things that we could do. This is something really quite concrete. There's quite a lot. I heard Greg, because I know his cough anywhere. There's quite a lot in. You probably know these ones, Greg. But there's obviously some in and around Seattle. As I move the map, we can see what there is. So that two. There we go. There's one. So this one is Clearwater Commons, and then there's the Songaya co-housing community. These are probably near you, aren't they, Greg?
They do look near, yes.
Yeah, I mean, I just go find, just look online, if you have to drive past, see what they are. If there's, if it's busy, there's lots of people. If it looks like they're going back to the Dark Ages, probably not worth the conversation. So that was my little idea, and I thought I'd just share it graphically. I shall stop sharing now.
So part of what we could potentially provide is more of the GLA part of the glocal approach. Like we could potentially help build the kind of coordination technology to kind of connect all this movement as more of a global thing.
Yeah, I mean, it is. There is, when you go to the website, you can ask about the organizational structure of it's called the Global Eco-Village Network. So it is global.
Okay, right.
So what you've got is all of those dots. The only way they coordinate is through their membership of the Global Eco-Village Network. So if we provided the Global Eco-Village Network with some coordination tools that they could use, that was trusted, secure, decentralized, from an organization that has common values with this global eco-village network, it would therefore make sense to sort of see if we could work together.
Yeah, makes sense to me.
And given that we've got to do the voting and the deliberation stuff, our cast and our vote, and we are indeed doing it, we even have a kind of a target application that might work.
Yeah, I was thinking that. I was trying to envision, how it would be manifested, and I guess it would, at first, at least, kind of center around like what we're building with RChat.
Yeah.
Do we not have Nora today?
No, Nora is sick. She emailed us this morning and said she can't.
Oh,
Yeah.
Oh, I'm so sorry.
Yeah. She said she wasn't feeling well, so she couldn't make it.
All right. Well, I'll send her some well wishes. Have we already? I guess we've already begun the call. So.
Yeah. It doesn't have the fancy Nora introduction, but yeah, we got started. Yeah. So one thing that Nora wanted to bring to the table was this article from about Microsoft. The headline is Microsoft's astonishing climate change goals explained. The company plans to wipe out all of its carbon emissions and keep going. So their plan is to be completely carbon neutral. Looking for the date of when. can't remember exactly. You can't see it here. 2030. So they want to, all their data centers worldwide, everything carbon neutral by 2030. And then their plan is to go further than that and go carbon negative so that they can attempt to reverse the damage that they've done up until then. It's a very ambitious plan. It goes through the various steps and stages of how they're planning on doing this.
That's great news. I don't know how they go carbon negative, but I'd like to hear about that.
Yeah, I don't know either. I'm just kind of reading through it here. But yeah, I mean, to me, it's just yet another example of the massive amount of investment that is being put in to the next industrial revolution. And I was just kind of commenting to Steve how in Jeremy Rifkin's book, which he released last year, the information is already out of date. In that he wasn't aggressive enough with his predictions about when peak oil demand would arrive. He claimed that it would be 2028, and it appears that it's 2020 when peak oil demand has arrived. So like the shift to the next economy has already happened, and to me, this article is just yet another example of that.
Yeah, I completely agree. I think your assessment is exactly right.
So I have some questions that I would like to ask, kind of centered around an interview that you did, Greg, back on June 25th with that blockchain blueprint.
Mm-hmm.
And it's kind of just connected to what you were basically trying to describe to him, what makes us unique and what our focus is. And I was just wondering whether I could just kind of bounce some thoughts off of you about what you said.
Sure.
Okay, so I'll just read some quotes from what you said. So you said that our focus is about self-organization by building a digital asset management platform. And I quote, "If you look at the last 20 years of the internet, it's all been about digital asset management, Facebook, Google, Spotify. If you want to build out a decentralized coordination infrastructure around self-organization, then essentially you must build a digital asset management platform. So that also uniquely identifies us. Bitcoin is a payments network. Ethereum would like to be more than a payments network, but it can't scale, so it's essentially a payments network. Neither of them are scalable enough to be a real payments network like Visa. But even if they could get up to scaling to be a good payments network, if you think about it right, does a payments network have what it takes to be a digital asset management platform? Not really. But if you were to start from a digital asset management platform, then build a payments network, that's easy. Digital asset management is much more complex than just payments. So our aim to provide coordination infrastructure dictates the markets that we go after first and the architecture that supports those markets and makes us unique in that way. Essentially, think of RChain as a decentralized database. It is more than that because it's also a decentralized computer, but it's essentially a decentralized storage and compute mechanism, and as such, you focus on different things. So Rholang is really the next generation sequel. It's a query language as much as it is a coordination language, so that makes our architecture very different than a lot of other architectures. So that's I just love that little kind of chunk there. It really, to me, it really kind of explains it quite well. but it also kind of gave me more questions.
Oh, good.
So one question is, one thing that's unique about us, as I understand it, is that we are literally putting assets on chain.
Mm-hmm.
So I'm just wondering whether you can explain a bit more about that works. Is it similar to P2P systems like BitTorrent in that the actual files are being stored and accessed in bits on all the computers connected to the network?
Yes, the actual files are actually being stored on all copies of the files are being stored on all the computers that are participating in the shard. All the validators have local copies.
Okay, and then would a user access those files in a similar way as BitTorrent, in little tiny chunks scattered around all the computers and then assembled later? Or does it happen, do we have to download the file?
So we don't, BitTorrent I think of as largely more of a routing protocol, right? So it's what it's trying to do is to hide certain things. Now you can compose those two functionalities. So for example, you could run RChain through BitTorrent, which is a very reasonable thing and something that is ultimately on our roadmap. But you know that problem has already been solved to a certain extent. So we're tackling the other problems that haven't been solved.
Okay, and so the other problems that haven't been solved are what?
Well, scalable consensus, for example.
Right.
A coordination transaction semantics, for example, right? All the things that you know are right front and center in our architecture, right? So as I talked about, so Rholang, if you ignore all the data transmission stuff, looks remarkably like a coordination language, right? So it's saying, you know, these events happen in this order, but these events can run in parallel, right? And that's how agents within the smart contracts, which represent computational agents, coordinate with each other within the network. But once you add the data transmission bit, now you have this ability to not only put complex data up onto the chain, the storage mechanism, but you also have the ability to query the data on the basis of its shape. So you're saying, right? And so then when you have an agent that is putting data up on the chain and an agent that's searching for data that has a particular shape, and when those two events line up, when they meet, right, then you have a notion of transaction, right? In the sense the data goes from one name, one storage location to another, right? And that is the sort of next gen notion of what a transaction is. And when I'm talking about transaction, I'm not talking about a financial transaction. I'm talking about what people measure when they do these TPCC benchmarks, right? The kinds of, you know, the kinds of transactions that have, you know, that the notion of transaction that got Jim Gray the Turing Award. That's the notion of transaction that I'm talking about and measuring. Does that make sense?
It's much bigger than money.
Yeah. It's all about the data.
Yeah. Okay. So you were kind of getting into another area that I was going to ask about. So also in that above talk, the interview, when talking about Rholang versus Solidity, you talked about how Rholang provides a query system for code so that you can search code not only for how it is shaped, but for what it does. It can generate query systems that will allow you to create code based on its structure and function.
That's not Rholang. That's operational semantics in logical form.
Ah, okay, great. So what is the distinction between Rholang and operational semantics in logical form?
Okay, so Rholang is it's effectively, it's a programming language, right? So it's built on different foundations than a lot of other programming languages, but it's essentially a programming language.
Yeah.
Operational semantics in logical form is the next level up. It eats programming languages and produces a type system. And then you can use the type system to do these kinds of queries. So what types do is they classify whatever the domain that they're built on top of, right? So in the case that they're built on top of a programming language, they classify programs. Since they classify programs, you can use types to say, hey, give me all the programs that are in this bucket, in this class, right? And now it turns out that this classification scheme, this way of sorting through programs, includes information about how the program is structured and how the program behaves, which is new kind of information. It's not the way type systems that you find in Haskell or Scala or Java or any language like that function today. But it is a notion of typing that has been under development for at least 30 years. Is that making sense?
I think so. I'm just a little confused about how Rholang integrates with. I actually have I'm trying. Whenever I write operation semantics in logical form on a piece of paper, which I've been doing a lot lately, I abbreviate it to OpSelf. O small p, capital S, small e, LF, just so that I have an acronym.
Okay, all right. So I understood.
Yeah. So I'm just trying to understand exactly. Still trying to understand how Rholang integrates with OpSelf, or how the two of them, if OpSelf isn't Rholang, how the two integrate. Okay,
so you can take this algorithm, operational semantics in logical form. I'll call it OSLF. Okay. You can take OSLF and you can feed Rholang into it, and then you can get a classification system for Rholang programs.
Okay, so you could feed.
Yeah, think of it like, so in functional programming, right? A simple thing about functions is your function has an input and a function has an output. So we might write a function f that returns an integer and that takes an integer. We might write it as something like int arrow int, because that denotes the types involved. So it basically, int arrow int just means there's a function, and the type of the function is it takes an int and it returns another int, right? So you can think of what Greg just said as being a function. And the type of thing that it takes is it takes a Rholang program. And the thing that it emits, that it gives back, is a type system.
It doesn't take a Rholang program. It takes all of Rholang. It takes the specification of Rholang, a spec for Rholang.
The spec, yes.
Right? So
which in effect is taking all possible Rholang programs, because the spec is the set of all possible Rholang programs.
So it is a little complicated, Daryl, for a couple of reasons. One is because this is happening at a level that most people are not used to thinking about. They're not used to thinking about something that takes a whole programming language and produces information about the whole programming language. They're used to things that take programs or things even smaller than programs. So this is a larger thing. But the interesting thing is, because it's an algorithm, we can code the algorithm in either in Rholang or something that Rholang can call. Okay. And what that means is that you can now enrich Rholang with new query semantics. So it starts off with its own built-in query semantics. All right. So it knows how to eat data of certain shapes and emit data of certain shapes. But then with operational semantics in logical form, you've increased its ability, its capacity to understand the shape of data, right? Because operational semantics in logical form is an algorithm that allows you to teach Rholang about the shape of data, such as all JavaScript programs, and then how to classify all JavaScript programs so that programmers can now use Rholang to search JavaScript programs on the basis of how they're structured and how they behave. Does that make sense?
It's a little above my head, but
Okay.
I'm still trying to wrap my head around how people would apply it. Like, so people wouldn't have to. People aren't bound to Rholang in order to apply OSLF.
No, they don't. No, it's an algorithm, and because it's an algorithm, they could implement it in lots of different frameworks. But and this was by design, right? I wanted it to be above any specific any specific programming language. But here's what I'm saying: if you were to implement the algorithm in such a way that it was accessible to Rholang, you could now use Rholang to query GitHub and search for programs in GitHub that do that behave according to some specification, like is this a bubble sort? Is this a FIFO queue? That kind of thing. And you could also use Rholang to query geometrical data, like where's the find me a route in this map that has no left turns that goes from A to B.
I'm just trying to figure out how does an algorithm create that kind of like incredible
power. Okay, right. Because what it so think about like the way machine learning works, right? Machine learning takes in a bunch of data and produces classification schemes for the data. That's essentially what it does. Whether you're using clustering analysis or neural nets, you're effectively coming up with categories, that have significance about the data. Right? That's what they do, right? So a machine learning algorithm eats a bunch of behavior, or a bunch of data like pictures, and says, oh, this is a picture of a dog, so it's a classification scheme. Or that's a picture of a cat, classification scheme. You see what I'm saying?
Yeah.
Right. So, so it turns out that models of computation have a lot more built-in structure than the kind of structure you might find in a data set of pictures. Right. Now, we would love to discover that, data sets of pictures have structure, but we don't know what that is a priori. But if someone is saying, I got a programming language, or I have a virtual machine, then we know for a fact that has a lot of intrinsic structure because of the meaning of the words a programming language or a virtual machine. And all such things, any programming language, any virtual machine, and a wide class of other things have to share this common intrinsic structure. And the OSLF knows how to eat that structure and turn it into a very powerful classification scheme. A classification scheme that can recognize the structure that programs have, because you had to say that up front in order to say you have a programming language, and knows how to recognize the evolution of programs, because you had to say that in order to have a programming language. So it can use the existing information to build a classification scheme. And once you have the classification scheme, then you can use it to go and query the programs in that programming language. Does that make sense?
Yeah, I'm starting to slowly understand it.
The difference is that, as programmers today, with the GitHub example, right? You can search GitHub, you can put in some words, bubble sort, blah, 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 but it relies on the author of the program having named it correctly. Well, what happens if they name their bubble sort algorithm, but they call it something else? You would never know.
Yeah,
right?
Daryl sort.
Yeah. So, whereas with this, I could say what I'm interested in is things that behave as a bubble sort should, regardless of what their names are. And it will tell me. So way back in, I don't know, 20, 30 years ago in computer science, there was a lot of work on reuse. And reuse was responsible for lots of misuse, as it turns out. But reuse was the sort of holy grail, because then if you can reuse code, then that's a line of code you don't have to write again. You just write it once and it gets used lots of places. And so reuse was everything that everyone wanted. And most of the reuse was around largely naming things. The problem was that if all that code was made available, as it is now with GitHub, nobody knows how to search it semantically for what the behaviors are. So, the promise of reuse was always missing a step. And the step that was missing is the identification of the behavior of something. So being able to say, I really want things that behave like a bubble sort. Notice the use of the word behave, because that's really the only way you know it's a bubble sort, is if its behavior is the same as a bubble sort.
So it just sounds like you're just talking about how standards weren't formed. So people had
no, it's not standards.
It's not standard.
Standards are things that we as human beings impose on things and other people so that we can share a dialogue, a common discourse. Right. This is actually mathematics. This is not by common consent or agreement in a standards body. This is just, it is.
So you can calculate. So like if you took a bubble sort program and you renamed all the variables to just machine generated strings, then the program would still, using the type that represents bubble sort, you would still be able to detect that it is bubble sort, even though all the names have been changed.
Okay, so the algorithm, the Oslf algorithm, is capable of detecting or identifying enough of the characteristics of something in order to say it is what it thinks it is.
Yeah, in order to determine its behavior.
Yeah. Now the important thing here is that it's not looking for specific behaviors, right? The input to the system is a type, which can be thought of as a query. Find me all the programs that look like this, right? So that's the one thing that the machine learning people don't have, right? They have to come with a built-in category like dog or cat or happy face or sad face or whatever it is, right? So we produce a query language in which you can write down a bunch of interesting queries, not just one. In fact, an infinite number of interesting and fascinating queries. Now, the subtlety to this is that sometimes you can write, just like you can write down programs that go forever. You can absolutely write down queries which it would take forever to decide. But it turns out that there are interesting sweet spots where you can detect interesting facts about programs and lots of other things. But you can detect interesting facts about these programs and it still takes finite time in order to do this.
And so those kind of those interesting correlations or whatever are what are being identified in the OSLF algorithm.
The OSLF algorithm generates the query language and the execution engine for running the query.
Generates the query language and execution engine for, what was the rest of that sentence?
For running the query.
For running the query.
So think about it like this. Like SQL is done by hand. There's one query language.
Okay.
SQL. And there is one algorithm for checking whether, you know, a particular group of tables satisfies or elements satisfies the SQL query. What we're saying is, you give us a model of computation and we'll give you back a query language. So it's not one query language, it's one per model of computation. And that query language, we also generate the mechanism by which you can run it against a source of programs. So it's a level up from SQL. Go ahead, Steve.
Yeah, so it generates. It's the equivalent of it generating. So, you know, in one embodiment, it takes something, and out the back, it generates, oddly enough, SQL. So it's generated the SQL language, right? But it doesn't. What Greg's saying is, it doesn't just stop there. It generates the thing that eats the SQL that enacts the query. The SQL engine.
So, okay. So now I'm trying to wrap my head around how OSLF applies to RChain. Is it a separate project outside of RChain, or, and if so, does RChain have perhaps like first player advantage because we are going to be utilizing OSLF?
So what I tried to, so it can be made separate, but here's the reason why you want to put it inside a blockchain project. Actually, there are multiple reasons. As soon as you have OSLF, then a bunch of data sources which had, you know, significant value suddenly become a lot more valuable. So like SwissProt, which is a massive database of proteins, suddenly becomes a lot more valuable because you can get much more information out of that database. Geolocation. Let me just finish, okay?
Okay, sorry.
All right. So a lot of that data becomes so valuable that it starts to identify people and information about people in a way that you would not want to be under the control of one corporation or one government.
Okay. Yeah, because like as you guys have been talking, I've been kind of thinking about how it would apply to almost like accelerating AI's capabilities.
Well, it can certainly accelerate AI, but even if you take AI out of the picture,
yeah,
it suddenly makes, so if you were to wed it to a blockchain and you started putting important information, public information on that blockchain, because the information should be on a public data source, right? Then that thing could potentially become much more valuable.
Okay, yeah.
Because now you can query it in a way that you've never been able to query it before. And so you can learn things about the public that you've never been able to learn before.
Radical transparency on steroids.
That's exactly right. And so you want it to be not in the hands of one party, but in the hands of, but in the decentralized setting where everybody has it.
Yeah.
That's why you put it, why you join it with RChain. Does that make sense?
Yeah. Okay. But I guess if you were Cardano, you could still potentially utilize OSLF, or could you? It's the architectural structure of
all of it's been
RChain.
made open source. I'm doing my level best to make sure that everyone has access to the information. There's no way anyone in hell can put a patent together on this, because I can point to over a decade of prior art saying, nope, sorry, we've reported on this here, 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 here. You can't hold that patent.
So is there something unique about Rholang and RChain that allows us to utilize OSLF in a way that other blockchains couldn't?
Yes, and that is concurrency. As soon as you have something like this, you now dramatically increase the number of data sources that you might want to coordinate against. Like, I want to, not just that I want to coordinate against that geolocation and that geolocation database, but I want to coordinate against that geolocation database and that supply of work records, for example. And as soon as you have that kind of situation, concurrency is at the fore. You now must coordinate in a concurrent fashion or you're screwed.
Mm. So there's some little observations that are interesting that result from all of this, particularly with concurrency, right? So you might have two programs that are running concurrently, right? Different threads on the same machine with multiple processors, or indeed different physical machines. If you don't know what their behaviors are mathematically, if you can't put a bounding box around the behaviors, you don't know whether they need to interact with each other or not, right? And you don't know whether the interactions that they have are actually the right ones. So you're in a position in a distributed system, which is most of the web today, where you don't really know for sure when two things run that one doesn't tread on the other, or that they don't get into some sort of deadly embrace and nothing can carry on and you have to reboot your machine, right? You just don't know. The way that we tend to deploy software in a world that's inexact like that is we try to test the hell out of it. But testing, as Dijkstra said, doesn't show the absence of defects of these issues. It just shows the presence of them, and then you go get rid of those presences by fixing the bugs, right? So if you have a stronger notion of type that's behavioral, then you can start to see where things can execute concurrently and where things need to synchronize and what is good synchronization. You can make judgments about that, and automatically. It's not like people have to inspect the code. The type systems will sort that out. They inspect the code. So to do this is kind of, Robin Milner always, he always wanted a world that was exact like that, that was much more predictable. There are still things that are unpredictable, but he wanted to make sure that types really were at the fore. I mean, he used to say types are the leaven bread of computer science. And what Greg's sort of done here is elevate the debate as to how you can deal with behaviors and what you can do with behaviors that would enable people to write programs, different parts of the globe, that actually could coordinate. And not only that, correct by construction.
Mm.
And the prior work, I mean, there's all sorts of prior work. There's interesting prior work. I was listening to Simon Peyton-Jones talk about Haskell and the journey of Haskell, which is quite an interesting YouTube talk. I mean, I guess you worked with Simon, Greg, I would presume. And all of that stuff on functional programming that's kind of like trendy these days, had its roots way back when. And a lot of what's gone into theoretical computer science and now new languages, including JavaScript and others, has its roots in some of that work. So formalization and the mathematics of it are really, you can't do computing without it. It's a shame, I think it was it was Dijkstra again, I think, that talked about the software crisis. Talked about the software crisis in like late 60s, which was simply that the number of requirements coming in exceeded the ability of programmers to actually deliver. And so you get this gap between what people need from technology and what people can have at any one time. And that's never slowed down. That's, as technology's got more available, smartphones and the like, and IoT devices, so that demand has risen. But nobody really at a commercial level, nobody really bothered much about doing it properly. It was kind of like the Wild West. They designed languages by committee. That's a really bad move. I think PL1, the specification versus the specification of Rholang, for instance, PL1 is in, 20 volumes of huge, big books designed by committee. I'd rather trust, if you go and have an operation, you don't have a committee of neurosurgeons all clustered around. One of them's actually given the job, right? And in the same way, you don't have a committee of computer scientists come up with a language. You kind of want it to be a really small number, right? It might be more than one, but the more people involved, often the more things get added for no good reason. And people often just do that with languages, which is why Java's got so big and things like that. So I think having a new language like Rholang brings that forward a step, and then having the ability to extract interesting properties from not just Rholang programs, but other programs, it would be very useful. I mean, for instance, you could ask the question in GitHub, give me all programs that, that do some sort of behavior that's biased towards, something we know that we can do in Rholang really easily. And then you could see all of the other ones in other languages that purport to do, that do the same thing.
So I'm seeing that, like, OSLF, I'm starting to understand the importance of it and how vital it could be in helping us coordinate quicker as a species.
Yes, that's the idea. Is it gives us a view into the data that we've never had before. That's why in 2000, I can't remember whether 2009 or 2010, the talk that I gave was 4 impossible queries, things you just can't even write down in an existing database, let alone consider executing. So that's the point. So as an example, here's a query I can write down in a system that has employed OSLF. So I start with a framework for expressing geometric information, Clifford algebras. I run OSLF on Clifford algebras, and I get a query language that allows me to look at terms, expressions in a Clifford algebra. Right, and expressions in a Clifford algebra represent geometric information. So they're talking about where things are in space, and the kinds of transformations that they might undergo, like twisting or other kinds of deformation. So using that system where I've run OSLF on Clifford algebras, I can write down a query like, find me all the wires that run from the nose of the airplane to the midsection that are likely to undergo a twist. Right? That means that I'm looking for wires that might be stressed, and if the fuselage flexes, they might be stressed to a point where they snap or become dysfunctional. Like, think about what that kind of query would do for airplane engineering or submarine engineering or bridge building or house construction, or you see what I'm getting at?
Yeah, but in order to get that kind of data back, wouldn't it have to be kind of entered in the right way in the beginning?
That was the whole point of making it an algorithm. I don't have to insist on a particular format.
Yeah.
You tell me the format that you're representing your information in. I generate a query language for that format.
So, so OSLF, is it done? Like, is the algorithm complete, or is it something that's continually ongoing? I've never made an algorithm, so I don't understand how it works.
So we believe that we have the algorithm. As with anything of this level of complexity and abstraction, it takes a long time, right? But what we've been doing now is testing what we've got against very, very high standards of quality.
Okay.
So for example, we know that by simulation, which is the notion of equivalence that underlies all notions of equivalence put forward in concurrency theory, and other notions of equivalency programs. So it's effectively the gold standard for notions of equivalence. Right. So we are testing that the logical equivalence that we get from OSLF matches up with by simulation. And we have a very interesting theorem. We're making sure that we've got the proof of that, but we have a very interesting theorem that shows how to do this extremely generically. Right. So we've had to come up with a new notion of by simulation. We've had to come up with reformulate, or I don't even know, an expansion of the notion of Levere theories. So all of this is groundbreaking mathematics, and so it's going to take the community bashing on our results and saying, "Wait, what does this mean? What's that mean? Oh, I'm not sure I believe this step." Right? That process has to go on, but we believe that we have the construction. And now what we're going through is the process of quality assurance. We tell our results. First of all, as in the same way that you've had these kinds of questions, everyone has these kinds of questions, right? What the hell are you talking about? What level is this? And then there's all kinds of level slipping as you go through the conversation, where people keep slipping back down to a more familiar level, and so on and so forth.
Way down there.
Right. Well, no, I mean, it's very common, right? I mean, even Mike and I, we would constantly be engaged in level slipping mistakes, right? So it's not, it doesn't say anything even about your experience. This is a new way of thinking, right? And so but the point is that the process requires a certain amount of engagement and investment, and it takes a certain amount of time. Just yesterday on Twitter, I had this long conversation, a long thread with Connor McBride, who's one of the most well-known type theorists on the planet, right? And it, just getting up to speed to talk about these things takes a long time, right? He doesn't know me from Adam, right? He's not going to trust that I know what I'm talking about. And so it takes this long sort of dance before we can get to substantive discussion.
Right.
Right. So that's, so I'm just trying to be transparent. This is where we are. We believe we have the constructions. We know what the theorems are that we're putting forward. And now we have to get the community to make sure that we haven't screwed up.
So how much of RChain's short-term success is dependent on OSLF's?
None. I carefully constructed the whole business model and architecture and everything. So RChain can just deliver.
Yeah.
Right? Like even if OSLF doesn't work at all, namespace logic does work, and so we still get the behavioral types just for Rholang. OSLF is like raising the game much, much higher.
What would be the ultimate fantasy goal of OSLF? Like, would it be as accepted as I still don't know. It's an algorithm, not a protocol, right? It's an algorithm that anyone can use. So what we want is like many implementations of this. Yeah.
Many people using it, right? but we want to protect it in such a way that no one gets to claim ownership of the algorithm. The best they can do is claim and implement ownership of an implementation.
Wow. Thank you so much for that journey. I really appreciate it.
No, I appreciate it as well. And I appreciate Steve's elucidations along the way. It's going to take a lot of people understanding what's going on and putting it forward. It's like with all of these ideas, right? Even now, people still don't understand. There's still a large community that doesn't understand the value of concurrency.
Mm-hmm.
Even just in blockchain, there's a large community that doesn't understand the value of concurrency and how hard concurrency is, right?
Yeah. Like you were saying before, like millions and millions of dollars being spent on something that just cannot scale.
Can't work, can't scale. Like you can just look at it with 5 minutes and go, nah, that won't work, right? And then you get more forward, like Rick Dudley is a fairly forward-thinking guy, right? He's really he's one of the brightest minds within the Ethereum community, right? But his level of experience gets him exposure just to the actor model, right? Like before Rick Dudley was born, I had already built one of the most high-performance actor model systems on the planet, right? And I spent 10 years while Rick Dudley was going to primary school. I spent 10 years using high-performance actor-based systems to build industry-scale solutions, and that's how I discovered. You know what? I used to be an actor bigot, but I'm not anymore. There's a lot of problems with the actor model, and I can list them. I can tell you exactly what they are, right? So the dissemination of information is slow going. It's very difficult. And likewise, after I sort of embraced the mobile process calculi and became a pi calculus bigot, I built one of the most high performance pi calculus based systems on the planet, and then I used it in real business applications. And then I discovered, oh, there are a lot of problems with the pi calculus too when it comes to real world applications. And I had all of this because of my experience. Right. And it's like, so very few people have that experience. And that's where the shape of Rholang comes.
Yeah. Oh man. Okay. So sorry, go ahead.
No, I was just, we're late for the staff meeting, but I was just, it's like getting across even that, like OSLF is like, light years past all of that.
Wow. Yeah. So next, maybe in another call, I want to ask more about your history and where you could identify where the birth of Rholang happened in your mind. Like, I'd like to know how, if that could possibly be, maybe it was when you were 3, I don't know, but I would just love to kind of hear more about the history of how you got here. I think it would be a fascinating several stories.
Sure, we might do those as Rcasts.
Yeah, that'd be great.
Cool. Well, thanks to everyone. We're late for the staff meeting officially, so maybe we should close it out here. Daryl, you want to be the Nora proxy? It's hard to compete with Nora, but
no, I can't. I'm not even going to try. I'm just going to say, Nora, please come back next week.
Yeah, be well, Nora. We miss you.
Get well. Yeah. Take care. Thanks, everybody.
Take care, everyone. Thank you.